One, two, one, two, one, two, one, two, one, two. Woo!
Hello, guys, and welcome back to this one exciting one today. Today we are going to be looking at merge sorted files. So we are now going into chapter 11 of the book, Element of Programming Interviews, where we are now going to start looking at the heap ADT, abstract data type, right? So it's an abstract data type in this because in the storage it holds the form of a list and then uses a formula 2i plus 1 and 2i plus 2 to determine its left and right child. But in our illustration of what it is, right, it is basically a tree, that a balanced tree where it's filled from the right way up. So yeah, we'll look into it, and we'll look into how this ADT helps us to understand or make solutions easier and more efficient, right? That's what it will help us to do. And for that reason, we would get into it, see these solutions, and basically build understanding around it. So the question for today says, design an algorithm that takes a set of files containing stock traits sorted by increasing trait times and write a single file containing the traits appearing in the individual files sorted in the same order. The algorithm should use very little RAM, ideally, or in the order of a few um, kilobytes. So yeah, so basically what that is in a nutshell is we have a folder holding files, and those files are holding digits, basically 3 digits, but they are all sorted. So we have a list and an integer. So that's the typing for for uh for what we are going to have subsequently when we get into it proper, right? So it's going to be a list and a tie and and a bunch of integers. And yeah, so and then what do we want to do? Those integers are sorted, there are multiple files. Now we want to pass it through an algorithm that would then pass us out a sorted list, right? A full one-liner sorted list. So that's basically what we are going to be getting into today. And we will see how we do that in a streaming sense, not having the data in the RAM already before before we begin to work on it. But it's going to be a stream sense where we will have some data coming, and then we will work on those data, and then we'll pass it out. Now, this so before we get into the brief talk, I'm just going to do a small example to bring home the idea of what the problem wants us to do. So we call this mesh sorted files, and we say while true, if A, that's the first array, has it does not exist or is empty, please print out all the B, because that's already sorted and it suffices for the sorted list. And if B does not exist as well, so we print out A. So that's just it for this line and this line. It says for not A, for underscore A in B, print out all B's. The same thing happens here as well. We now go ahead to say else if A is equals to B at that first index. So just like a situation where we have 4 and 4, right? It says go ahead to print A. So why do we boldly print A? Because when we print A and 4 leaves this guy, what happens is that when it comes around again, it will consider 4 and 23, and then 24 will still make it out. So basically, that is okay for us to choose one at a time. So we now say else if A is greater than B, obviously we print out B, because B is the lesser, and we're trying to create a sorted list from the smaller to the greater, right? And the same thing for A. If A is the lesser, we take we take A's pop and then we create that. We help it to complete the list, right? So if that's the case, we can then go ahead to, sorry about that. Sorry, I think that's, so we go ahead to see our solution, where we say show let, we say 1 2 3 4 4 9 6 7 23 90. So that's it for this. We can see that the solution is come alive and it works. And yeah, that's basically not the idea of what we're trying to do, because we're not trying to hold the data in we're not trying to write an algorithm that will take the data into in hand, but basically an algorithm that will stream it in. So it should just stream it in. It will not have the whole context at first. So it will just stream it in. and as these values come in one after the other, it will be able to manage it. So that's it for this one. So tomorrow we are going to be looking into the solution around uh, the brute force. We're going to looking at the code explanation of the brute force and how it tries to get around solving this in a streaming sense, and then we take it from there to continue into the graph, the debugger, then the complexity. So that's it for this one. Muchas gracias. Bye.